Okay, here goes. I'm going to just summarize what was already covered in Miss Cleveland's video that I sent to you guys. A few of you just wanted me to kind of go over it one more time and maybe show a little bit more of the calculator work and maybe even finish up the notes that she was unable to finish that day. And then if there are any other questions, of course, you can ask me in class. But as far as this part, the introduction, I will have you go ahead and read that on your own. And of course, any questions that you have with this portion, we can cover in class. I went ahead and did example number 1. We'll talk through it together right now. But this was sort of a review of what we had already been doing. Again, you were given in this problem 2 parametric equations. X was written in terms of t. Y was written in terms of t. Domain was given. So put the domain here, -2 all the way to +3. And then I just started substituting these values into the respective equations. I showed a couple of points being substituted into the equations for the x and the y. I showed my work. I didn't do it for all of them, but here we go. X of -2, when I substituted it into this equation, -2 squared minus 4. Anything squared has to always be positive, so 4 minus 4 is 0. And then 1 minus 4 is -3, 0 minus 4 is -4. And so that's where I'm getting these values here from. So you can do that a couple more times. I did the same thing for y. Y is written in terms of t, so whatever t value, I substituted it here. So this is function notation. I'm telling you what I'm substituting here on the left of the equal sign, and here I'm actually substituting it. So y of -2 is equal to -2 divided by 2, simplified to -1. Y of -1 equals -1/2. You can use the decimal value if you feel more comfortable. And y of 0 was 0 divided by 2, which is 0, and I repeated the process to find these other 3. And then we just took these 1, 2, 3, 4, 5, 6, and plotted the points in those respective spots. And as I plotted them, 1, 2, 3, 4, 5, 6 points going from t -2 to t equals 3, I noticed that my direction kind of went left and then back to right again. So it's kind of a halfway parabola sort of sorts. And I provided the arrows for directionality. I labeled each time for the dot. And notice I did change my scaling. I did skip that part. My x scaling went from -4 to +5. So on the x-axis, there was no need to change that. I had enough space. I had enough space on the y-axis, but my parabola, my sideways parabola, was going to be really tight. So since the numbers were very small, they only fluctuated from -1 to +1, I decided to split up the scale and count every 2 boxes as 1 unit. So in other words, my y scale was a half. So I make sure to stipulate your scale if you do change. That's very important. Okay. All right. So then let's move on to the next example. So I kind of got a head start here. By the way, all this portion here, we also went together in class. The mode button is where you will set your mode to parametric when you're trying to graph your parametric functions. And then the xt, theta, n, that is with respect to each one of those sections. So parametric will, generate the t values. If you want to go back to our normal graphing of functions, it will go back to using the x value. But anyway, here in example 2, it kind of changed up from what we were doing before. Okay, so here's what's going on in this problem. Notice that instead of x equals and y equals, it's not written in terms of t. It's kind of like switched around. So here t equals x over 2. What I did is instead rewrote this equation so that I did have my x solved for. So the 2 is dividing, so I'm moving it over to multiply with the t. So 2t equals x, but I like having x on the left side of my equal sign, so x equals 2t. So I took my domain values, I plugged them in here, and here again is my substitution work showing you how I got these values generated. So x of -2 was 2 times -2. giving me -4. X of -1 is 2 times -1, and so forth. So I got those values. So let's look at what we'll do for the y values. All right, so for this part, you can do two things. You can just go ahead and leave y written in terms of x. And the reason why you can do this is because we already have our x values. So it's our x values that we will be substituting here to generate the y values. You can also do the following. If you like, no, I really want to plug in t values into my equation, you will have to rewrite the y value in terms of t. So in other words, you will need to take, you see x equals 2t, you would need to put the 2t here and the 2t here and simplify it. I'll do it really quickly, but I honestly think that's the harder way. But for instance, you could do this. 1/4 instead of x, I'm going to write 2t minus 3/2 2t plus 9. And then I'll have to do some simplifying of work. And this is where I'm scared if you do it this way, you make some silly mistakes. But 2t squared is 4t squared, but 4t squared divided by 4 is just going to be t squared. And these two are going to cancel out. So you're just left with minus 3t and then plus 9. So here's your new y equation written in terms of t. And so when I do substitute, so for instance, I want to use the t values, I could say, well, y of -2 will be -2 squared minus 3 times -2 plus 9. That will be 4 plus 6 plus 9. That's going to give me 19, right? No problem. But here's the thing. You don't need to do all that work if you insist, go right ahead. But here's what I'm suggesting. If it's written in terms of x and you already have x, why do all that extra work? Because if I use this formula already, so for instance, I needed this value, right? And x is -4. Using this equation, y of 4 would equal 1/4 x squared. So 1/4, my x was this, minus, it's so hard to write this in because I don't have enough space, 3/2 4, and then the plus 9. Okay, it's really, really tight. This is 16 divided by 4 is going to be 4. This is 4 divided by 2 is 2, then times -3 is 6, plus 9, and something's going on wrong. What did I do? What did I do wrong? Oh, -4. Hello. I was doing something wrong. Okay, so this makes it plus. And then 4 plus 6 is 10 plus 9 is 19. Okay, so notice you'll still get the same answer. Now, please, 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 I know I just did a whole bunch of head math there. Because you guys are teenagers, I mean no offense, okay? Let's go to mode and make sure, wow, this is really dark. Okay, so let's go to mode and let's go back to function here a second. And let me see if I can make this darker. No, that's not helping. Okay, so let's type in this part right here. Actually, let me show you this trick. I don't know if this is going to confuse you or not, but this is really, really cool with these calculators. So this is our equation right here, right? 1/4 x squared minus 3/2 x plus 9. Instead of doing this, so I'm going to show you one way. 1/4, 1 divided by 4, then parentheses, my x is -4, and then I have to square it. And then I had to do minus 3/2 minus, open parentheses, always put fractions within parentheses, 3/2 times -4, and then I had to do plus 9. So there's, I'm typing that whole thing, and notice I get 19, right? It's a real pain having to type in -4 every single time. Here's one thing that I suggest students to do, and it really, really works every single time. Type what you are substituting. So I needed to substitute -4. So what I would want you to do is you go over here, okay, and I'm going to say, okay, I need to type in -4. So I'm going to do -4, And then I'm going to hit this store button right here, STO, that's for the word store. And I want to store it where? I want to store it as my X value. So this is what your calculator would look, okay? So -4, store in X. And then hit enter. Tell the calculator, you know, oops, I hit clear. Hold on, let's do that again. So -4, store in X. And then you hit enter to tell the calculator, okay, so anytime you type in X, it's going to be -4. And just to prove your point, like if I say 5X, that means 5 times -4. Let's see if what comes out, -20. If I put 2X, that means it's 2 times -4. Okay, so the calculator will evaluate it for me. So what I'm saying is, right now my calculator stored -4 as X, so all I need to do is type that equation as I see it. Okay, so I don't have to worry about substituting or anything. So I will do, let's see, it's going to be 1/4 X squared minus 3/2 X. So I'm going to do alpha Y equals 1/4 X squared, and then it was minus 3/2 X. So minus alpha Y equals 3/2X. And then what was the rest? Plus 9, hit enter, and look how it just does it for you. I'm done. So there's the 19. Let's do it for the next one. So the next one is -1, right? No, sorry, we're plugging in X's. -2. We'll just tell the calculator, -2, store in X. I'm going to hit enter, right? And all I do is do this. Go up. I'm going to hit enter to bring this down, and now it's going to substitute -2 for me, and that's where I'm going to get the 13. I'm going to do it again. I'm going to type in 0, store it as my new X value. I have to hit enter, and I'm going to arrow up, hit enter to bring it down, to copy paste basically, and it's 9. So I'll put 9. And so I'll repeat that process. Let's try 2 there. 2, store X, arrow up, hit enter, enter again, I get a 7. Okay, so that's how you get those values. So you can choose either way. This is an alternative way, but I just think it's just too much extra work. If it's written in terms of X already, use the X values because you already have them, okay? So I'm going to put alternate here, but it's, I think, I'm going to write preferable over here. Preferable, okay? But you obviously have to make that choice for yourself, okay? And then let's plot. So, let's see, I think I decided to count X and Y scale here by 1 because we kind of have a long axis here. So -4, 19. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to make a mark here for myself. 11, 12, 13, 14, 15, 16, 17, 18, 19. So this was -4, 19. Okay. It's kind of hard to see right here. And then -2, we had to go to no. Oh my goodness. That's right, -2 to 13. So here's my 10, 11, 12, 13. And then I had to do 0, 9, 0. Here's my 9. And then 2, 7, 2, let's see, that's 10, 9, 8, 7. 4, 7, 2, 4, there's the 7. And then 6, 9, 6, and there's the 9. So here again, we'll have, you know, like not a segment, but we're not going to go past those dots because it's closed, a closed interval from -2 to +3. But again, you can see this is sort of a parabolic shape. And we went from left to right when we were graphing. And so we will include those arrows, and we'll include the t values near each dot. There you go. So, let's do this next one. Alright, so we went ahead and put in our domain. We are going to rearrange this so that we isolate for our x. So I am going to, let's see, I want x by itself, but I want x positive. So I'm going to move this x over the side. So negative x is going to become positive x. So t plus x equals 2. But then I need to subtract the t. I need the t to move over because I want x to be by itself. So x is going to be 2 minus my t. Okay, so there's my x isolated so that I can substitute these into there. And let's see, showing work over here for a few of them. So I'm going to substitute x when t is negative 2. So that would be 2 minus negative 2. The two negatives next to each other yield a 4. X when I substitute negative 1. So that will be 2 minus negative 1. I guess I could have put parentheses here to kind of give a better visual. That will be 3. And keep doing that, and you'll get those values. To find my y, I need to substitute t or x. My y is written in terms of x, so I need to make sure I substitute these values, not those, okay? So I need to substitute those values. So I'm going to do y of, what am I substituting for? Y of 4 is going to be 1 over 2 times 4, so that's 1/8. So I'm going to put 1/8 there. If I do y of x, remember I'm doing the x's, 3, it's going to be 1 over 2 times the 3, so that's 1/6. And if I keep doing that, I will get these answers. Now, the thing is, when I get to 0, by the way, and I substitute it into this value, I'm going to end up with 2 times 0, which is 0, and 1 over 0. That's an undefined value. So I'm going to use the word U and D for short, not the word, the letters U and D for short. For undefined, it's not a number that we are able to graph. It doesn't exist. And negative 1, when substituting it, they give us a negative 1/2. Okay, so here is another sort of points that we're going to have to graph. And we are going to see that we have some very small numbers here. So my suggestion is, let's see, we had to go from 1/8, 1/6, 1/2. So how about, let's count by eighths. That's what I'm thinking. Yeah, let's count 1/8, 2/8, 3/8. Yeah, let's count by eighths. The x-axis will keep it the same. So let's do this. Let's say the y scale is 1/8. I know you guys don't like fractions, but I promise you that the graphing will be prettier if we counted by these eighths. So let's go. 4, 1/8. All right, so here we go. 4. 1, 2, 3, 4. And then, whoops, I can barely see. 4, 1/8. So here is 1/8. Okay? So 1/8, 2/8, 3/8. I'm going to put here 4/8. 5, 6, 7, 8/8, which is 1. Alright, so that's 1/8, 4 1/8. 3, let's leave that for a second, I'll tell you why. 2 and 1/4. Now, 1/4, if I wanted to count it in eighths, I needed to multiply this by 2, so I need to multiply that, that's 2/8. So 1/4 is the same thing as 2/8, it's equivalent. So let's go to 2 and go to 2/8, 1/8, 2/8. Right there. And then 1, 1/2. Well, 1/2 is half of 1. It's the same thing as 4/8 if you're not sure. check it out. I need 1/2 to be written in terms of eighths. If I multiply this by 4, I have to multiply this by 4, so it's going to be 4/8. So it makes sense that 1/2 is right here. So 1 comma 1/2. Undefined for 0, so that means there's an asymptote. Anytime you see undefined, there's an asymptote. So at x equals 0, we have a vertical asymptote. So we're going to draw a dashed line here to depict this vertical asymptote. And I should have done it with a ruler. Okay, and then we can put here x equals 0, and we can put VA for ourselves to just give us an idea what we did. And then at -1, it's -1/2. So at -1, it's -1/2. So we know it's -4/8. So 1, 2, 3, 4. So we just put a little dot there. Bam. And as far as the 6, if you see what's going on, I'm going to do this. I can see that it's a curve like this. So I'm kind of cheating when it comes to my graphing. So 1/6 was at 3. So 1, 2, 3. So my 1/6 is right here. So that's why I said let's hold off on that 1/6. Because to convert 1/6 to an eighth, see, 6 is not a multiple of 8. So it's not something comfortable to be able to graph. So that's why I skipped it. And so now we graphed from right to left, so we'll put arrows showing that, and then this random dot over here on the left. And what am I doing? Oh, I need a label. So t equals -2, and -1, and 0, and 1, and 2. And hopefully you do recall that with this, if we had to combine this into a rectangular equation, these parametric equations, the equation would be that where the graph would generate a side like this, and the other side is going to be like this. It's going to be an exponential. Okay? That's what it was supposed to look like. But anyway, that's that graph right there. And so hopefully you will feel a bit better about that. Let us go to the other side. I'm just going to talk you through this problem because again it's just repetitive. It's just having you guys use more of it as an application to a real world scenario, and obviously real world scenarios are a lot more complicated than this, but we just want to give you a general idea. So again, we wrote the equation in terms of what did I do? Yeah, I rewrote the equation in terms of, how did I do that? I have no idea. X plus 2. Anyway, I have no idea where I wrote that. So anyway, 0, 1, 2, 3. I chose those values because it's the path over 3 seconds, so starting from when the time started to it ended. And I plugged in those t values into here to get those numbers. And then I plugged in these t values into here to get those numbers. I plotted it. You can see the linear equation here happening. It went from left to right. It asked where am I going to be in 2 seconds? Well, in 2 seconds, here's t equals 2. It's pretty quick to find. I'm at where? The location was 0, 5. So it gives me the position as if the groom was a graphing, you know, what do you call that? A coordinate plane. So I would know exactly where in the room this student is located. When will I be standing at the front of the room? Well, based on this pathway, if it continues going, if I did continue past 3 seconds, I know that I would arrive to the front of the room at 4 seconds. And you could see, if you recall your linear equation knowledge, it has a slope of +2 continuously. So 1 rise over run of 2 over 1 would arrive to t equals 4 on the next plotted point. So that's where that came from. And to eliminate the parameter, that's what we did in the last unit. We just, oh yeah, that's why I did that. My goodness. I solved for t over here in terms of x so that I can substitute t into this equation. And that's what I'm doing right down here. So x plus 2 was replacing this t value, so 2 times x plus 2 plus 1. I ended up distributing and got 2x plus 4 plus 1, combine like terms. And what I wanted you to connect with was this does imitate the equation, the slope-intercept equation of y equals mx plus b, okay, where our m would be the slope and my b value would be the y-intercept, which is 5. And that makes sense because y-intercept is where the line crosses the the y-axis, so 1, 2, 3, 4, 5. Slope is the rise over run, so that's rise of 2 over 1 if you wrote this in fraction form. So it makes sense why our rectangular equation came out to look like a linear function. So moving on to example 3 and 4. These were different. So let's look at these now. Okay, so let's tackle this one. So here we're going to have x and y parameters that are including trig functions now, okay? So when doing the trig functions, it's recommended that we use these angles because they form the quadrangles and they're just easier and cleaner to work with. So if you notice what we're using here, 0, pi over 2, so we're using the 0, the pi over 2, the pi, the 3 pi over 2, and we wrap around to make 2 pi, okay? And we rather use numbers 1, 0, 0, 1, 1, you know what I mean? Those are easier to substitute in to get, those clean numbers to be able to plot. So let's do some work here. So I'm going to actually shift this paper over and do the substitution work over here in the margins because I need to use this space for the other meaty stuff. So let's start here. So I'm going to shift my picture over here so you have kind of a dual thing going on here. So when t is 0, we're going to plug that in over here, right? So I'm going to come over here. So I need to find x when t is 0. Let me scoot this over. I don't know how much space I need. So x when t is 0 is going to be 3 plus 2, and then the cosine of 0. Remember, cosine are my x values, sine are my y values. So the cosine of 0, there goes my thing again. So the cosine of 0, well, at 0, cosine is a positive 1. So I'm going to put in a 1 here. And so 3 plus 2 would give me a 5. Okay? I'm going to plug in when x is pi over 2. That's going to be 3 plus 2 times, well, when x is pi over 2, it's a 0. Cosine of pi over 2 is 0. So I'm going to put in the 0 here. Well, 3 plus 2 times 0 is just going to be 3. When x is pi, that's going to be 3 plus 2 times what? Let's shift over here to pi. What is my cosine value of pi? Negative 1. So 3 plus negative 2, it's just a positive 1. So you just keep doing that, wrap your way around, and I'll do it for each one of these since it's a bit different. Cosine value is 0. And I'll shift this over. And then we'll do it again for, my phone keeps dying. 3 plus 2 times, and then back to 2 pi, our cosine wraps back to be a 1. Okay, sort of a cyclical thing. And 3 plus 2 times 1 is a 5. Okay, you would do the same thing for the y values, okay, but this time, of course, when we find the y values, when we're finding the y values for here, we're looking at the y coordinate on the unit circle. I want you to get confused here. Let me write this of unit circle because I want you to know the difference. Because I know we're using x and y here and then x and y here. I'm just meaning of the unit circle. Okay? So of unit circle. So let's look at y of 0. Y of 0 is negative 1 plus 3 times the sign value. So negative 1 plus 3. Let's turn this back on again. So the sign value is y. The y value this time is going to be 0. So that makes that 0. So this answer is negative 1. The y value at pi over 2 will be negative 1 plus 3 times. My y value at pi over 2 is going to be a 1. So that's a 3. 3. So negative 1 plus 3 will give me a 2. Right? And let's do pi. Negative 1 plus 3 times. What's my pi? Y value. The sign is 0. Three pi over 2. 3 pi over 2. The sign is negative 1. Negative 1 plus negative 3. And last, wrap back around. And at 2 pi, you go back to the beginning where our y value is 0. Okay. So let's go plot these. Okay. So when we plot these, we are going to start with 5, negative 1. So here's our 5, negative 1. And then the 3, comma 2. And then 1, comma negative 1. 1, comma negative 1. That's kind of weird. So we're going like this, and then we're here. And then 3, and we're backtracking. 3, negative 4. Am I at the right spot? Okay. And then we go back to 5 and negative 1. So we started here at 5, negative 1, went here, 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 and went back. So notice it had a cyclical rotation, and hopefully you are seeing something about why this is in this section. Okay? So if you are not seeing it, it's because it's supposed to be an ellipse. The conic of an ellipse. Okay? And I'm trying to, there we go. Yeah, alright, there we go. I'm ridiculous, am I not? Trying to make it perfect. Oh, it bothers me so much. I'm a weirdo. Okay, so here is our graph, but there was something more they're asking us to do. Oh, let it go, Hanlon. Okay. That bothers me so much. Okay. Direction of my parameter. So I started here and I wrapped around. So don't forget those arrows. And so drawing those arrows. Bam, bam, bam. Okay. So that's the direction. So it looks like an ellipse, right? And so yay, belongs to this unit. So what else do we need to do? So make a table of values, done. Sketch the curve, done. Indicate the direction of your graph, done. Eliminate the parameter. Okay, so here's where things are a little different than what we're usually doing. So what we need to do is the following. This is the first time you're doing this, but so this is going to be like, why are we doing this? And you'll see why, okay? So just hang in there. So I want you to take the first parameter, x equals 3 plus 2 cosine of t, and I want you to solve for the trig function cosine t. So I want us to solve for this, okay? So I want us to isolate it. So we need to get rid of these two numbers. This number is the first thing you'll get rid of. So it's adding with 2 cosine t, so I'm going to move it to this side and subtract it. Now, cosine t is almost all alone, but I need to get rid of that too. So I am going to divide by 2 on both sides because the 2 is multiplying with the cosine, right? So now that I divide both sides, that cancels that out. So cosine is isolated. So I'm going to move cosine to this side. Cosine t cosine of t is x minus 3 over 2. And I'm just going to hold on to that for a second, okay? And, wow, I barely have any space here. All right, let's do the same thing for the y equation. And we're going to isolate the sign, okay? So move over the y, the negative 1 to the y side. And then, like I did over here, get rid of the coefficient of sine by dividing both sides by 3. So sine of t equals y plus 1 over 3. So why did I do this? Okay, so here's the reason for all of this, okay? And I'm going to draw an arrow here and hopefully we can fit it up here. Do you recall from last semester the Pythagorean trig identity, cosine squared x plus sine squared x, and what it equaled? Hopefully you remember that, right? So, if you notice, cosine squared plus sine squared equals 1, we are going to take this and substitute it up in here, okay? But here's the thing. If I squared this, right, wouldn't this become this? Right? X minus 3, I'm putting it to the second power, and I'm just going ahead and squaring that, and it's becoming 4. Okay? Let me do the same thing to this one. Because I need a sine squared, I'm going to square this. If I square this side, I must square this side. So my numerator, I'm saying it's squared, and I'm just going to go ahead and square my 3 and make it 9. So what I'm going to do is I'm going to substitute these values into here. So instead of cosine squared x, which is this right here, or cosine, let's do this. Let's just take away the x's and make it t. Okay, and make it easier for us to understand. Okay? Instead of cosine squared t, I'm going to write this, because I'm trying to rewrite it in rectangular form. I don't want t values. So I'm going to substitute x minus 3 squared over 4 for cosine squared t. So x minus 3 squared over 4 plus, instead of sine squared, I'm going to replace it with this one. Y plus 1 squared over 9 equals, and then I'm putting the 1. Do you not notice what's going on here? It's the graph of our ellipse. Notice we have an ellipse equation. Remember, ellipses are the ones that add. We have the center is supposed to be 3, negative 1. Let's see if we were right. 1, 2, 3, negative 1. Holy cow, it was. See that? We see that it's a vertical parabola, vertical ellipse. Well, our a value was underneath the y. Okay, so we had a equals 3, right? We had b equals 2. Well, 1, 2, 3. 1, 2 for our b. So it's pretty cool. Let's see. Our two parametric equations here, if rewritten and eliminated the parameter t to write it in rectangular form, that would be the graph of an ellipse, which matches what we have sketched. Pretty cool, I have to say so. Okay, so hopefully you find that a little bit easier. Let's see how we would do this one down here, now that we know what we're doing with the Pythagorean identity. Well, let's just go ahead and give ourselves a reminder here. Pythagorean identity. Just in case you forgot the words. Alright, so down here we have x plus 5 all squared plus y minus 2, over 9 plus y minus 2 squared over 16 equals 1. We know we have an ellipse, okay? This here is an ellipse formula, okay? And it's also written in rectangular form. Okay, and it's written in rectangular form, okay, because it's written in terms of x and y. And you can't see what I wrote, so let me scoot over. So our goal is to write the conic section, this here, in parametric form. So we want to write it in parametric form. And we are given that cosine squared plus sine squared is equal 1. All right, so we know that cosine squared t plus sine squared t equals 1. So we know that the cosine squared belongs to that, sine squared belongs to that. Okay? So let's solve. Set them equal to each other. So if I know that x plus 5 squared over 9 equals cosine squared t, we're going to do the reverse now. Square root both sides. So that removes that squared at the top. I square root 9. If I square root that, it gets rid of the squared. There's my cosine function, right? But I'm trying to go back to x equals, right? So I'm doing all the opposite I did here. I'm backtracking. Like I'm right here, and I'm backtracking. You see what I'm saying? You're just going backwards. I'm going to start here, and I'm backtracking. That's all you're doing. So this 3 needs to go back. So x plus 5 equals 3 times cosine t. It was dividing on this side, now it's multiplying on this side. I want my x by itself, so the 5 needs to go back over there. X equals, the positive 5 becomes negative 5 plus 3 cosine t. So, see, it goes back. Whoops, you can't see what I'm doing. So it kind of looks like what we did at the top. Okay, see the form? It goes back. Let's do the same thing. Backtrack. Sine squared t is y minus 2 squared over 16. So sine squared t equals y minus 2 squared over 16. Square root both sides. So sine t equals y minus 2 over 4. Square root that, square root that. Backtrack. I want y to solve for y. So let me put here, solve for y. Here we needed to solve for x. Okay? So let me shift this over again. Oops. There we go. This 4 comes over. 4 times sine t equals y minus 2. This 2 comes over. 4 times sine, or just put 4 sine t. And so 4 sine t plus 2 equals y, or you could say 2 plus 4 sine t, either or, and you're done. So here is your parametric equations written in terms of t. Okay, pretty neat. So I'm going to finish up here with example number 5, and then you can do the u-tries. But here's what you would do here, okay? So here you want to recall the Pythagorean identity. So here's another one. So Pythagorean identity again. And notice this time that this one is the minus Pythagorean identity. So you're supposed to have like an aha moment. I'm going to put aha, where you would notice that this one would have to do with the conic hyperbola, okay, which involves the minus. So just like you did the sine squared t plus cosine squared t equals 1, you're going to do the same thing with this one, where we will go ahead and write this down here so visually you can see it better, what's going on. C squared minus secant squared minus 10 squared t equals 1. So notice they all match up, right? So given that this is belonging to that ratio and that's belonging to that ratio, let's write it down. So let's do some algebra. Y minus 1 squared over 25 is equal to secant squared t. we will square root both sides. So the squared disappears. That becomes a 5. And we solve for secant. And let's do the same thing for the other side. X plus 3 squared over 4 equals the tan squared t. Square root both sides, so x plus 3 over 2 equals the tangent of t. And we need to solve for the x and y coordinates. So if I'm going to solve for y over here, the 5 goes first. And then the 1 needs to go. Oops, forgot the 5. Oh, sorry, I'm all crooked. So there's that. And then it's likely the same process, solving for x. The 2 goes to the other side. And then the 3 needs to pop over as well. Positive 3 becomes a negative 3. And I've isolated my x. And there is my x and y parametric equations written in terms of t. Okay? So I would like you, if you haven't as yet, try these on your own. I will give you the answers, but I want you to work them out on your own. Let's see, x equals 3 cosine of t minus 1, and y should be 5 sine t plus 4. Should be the answer for those. And this bottom one, the answer will be x equals, negative 8 plus 2 tangent of t, and y is going to be 10 plus 6 the secant of t. So see if you guys can do that one on your own, and if you have any questions, let me know. And as usual, thank you for listening. So sorry that this lesson turned out to be as long as it was, but hopefully it helps.